And welcome to Algebra 2, Module 1, Section 1 is what these notes are all about. Of course, my name is Mr. White. Make sure while you're going through these sorts of videos that you have your papers that I gave you. This is the entire packet for Module 1. So we're just going over the first section, which is about solving equations. There's a couple other sections in this module about solving absolute value equations. You're going to learn what that means. Also solving inequalities, as well as a thing called interval notation we'll go over in this section. So some of this will be review, maybe some of it's new from Algebra 1, so we'll just see. Let's get to it, and let's get to the notes here. So I'm working with an iPad here, so forgive me if I make some goofs here while I'm trying to go through this. I will try to go through it as quickly as I can in a similar manner to how we would do in class. Now I encourage you to pause and start this video as you need it, and maybe rewind if you miss something. Maybe you zone out for a second. That's perfectly understandable. Just go back and fix it. Just go back and watch it again until you get it. All right, so in this particular section, I like to lead with a word problem here. And then normally in class, I'd have you maybe work together and see if you could come up with a solution without me telling you anything. So let me read it, and then I encourage you to pause the video and see if you can figure out the answer to this. Floyd is an aspiring musical artist. He has a record contract that pays him a base rate of $200 a month and an additional $12 for every album that he sells. Now we know that he earned $644 last month, so the question is, and I didn't have this typed here, but the question is, how many albums did he sell? We could actually figure that out here since we know what his pay was. His pay was $644. So go ahead and pause the video and see if you can figure it out on your own, and then I'll go through the answer. Okay, let's go through this. So we want to set up an equation because we know his paycheck equaled $644. So what makes up his paycheck? Well, there was the $200 part, and then there was added to that $12 for every album. So I'm going to use 12, and you could use N as in Nancy or number. I like to use X. Most students do too. So 200 plus 12X equals 644. There's your equation. Now we're going to go over here in a second about how to solve these, but I think you remember from Algebra 1, you minus 200 on both sides. 12x equals 444. And then that 12 is attached to the x by multiplication. So how do you undo multiplication? Well, you divide both sides by 12. Divide by 12. And we're going to get x equals. Now you might need to go to calculator at this point. I have one off to the side here, ready to go here. So 444 divided by 12 equals 37. It came out exactly. So that's not a surprise since you can only sell a full album. 37 albums. Always put your units. I like to circle my answer so that it's real clear where it's at. All right, so hopefully you all got that right. There's probably other ways to solve this problem, but I wanted to show you how to do it with an actual algebra equation. Let's go to the next page here. So let's read this. Marcia has just opened up her new computer store. She's very excited. She makes $27 profit, which isn't a lot, on every computer that she sells, and her monthly expenses are $10,000. That's a lot. So she's got to sell a lot of computers. So we're going to figure out how many computers she needs to sell so that she doesn't go under and have to close, right? That's a pretty important problem if you're a business owner. So go ahead and pause the video, see if you can figure this out, and I'll go over the answer here in 1 second. Okay, so her expenses are $10,000, and we want to know when will the profit equal that. So $27 for every time she sells a computer. That sounds like multiples of 27. So 27x. All right, let's divide both sides by 27. Now this is kind of a weird problem. I don't know how to do this in my head, so I'm going to go back to my calculator, and I'm going to type 10,000 divided by 27, hit equals, and what do we get? 370. So does that mean she needs to sell 370? No. She needs to sell one more to make an actual profit, because the question was how much does she need to sell to actually make a profit? So it would be 371 computers. I'll put PCs. Maybe they're Macs, but anyway, Okay, so hopefully that's helpful. We can't sell 0.4 of a computer, so she had to actually go to 371. All right, let's go to the next slide. Now, these next couple are super simple. You can do this in your head like you do it in the grocery store. So you go into the grocery store and one bunch of seedless grapes costs $2. So the question is, how many can you buy if you have $18? Well, it'd be multiples of 2, right? So 2, how many multiples of 2 do you need to get to 18? That's pretty obvious. The answer is 9. And you probably knew it before I even started, but I wanted to show on an easy problem how to use algebra to solve it, because sometimes life isn't easy and we actually have to write things down and show our work. Now, if you can buy one bunch of seedless grapes for $2.59, see, this is getting a little crazier, then how many can you buy with $18? So this gets a little bit, and I goofed there. I forgot to put my variable there. Hope you probably caught that. So 2.59x equals 18. So how do you undo the multiplication? Because after all, the 259 is attached to the x with multiplication. So how do we undo that? Well, with division. 2.59 divided by 2.59. And let's go back to our handy dandy calculator. And we get 6.9498. Now, do we round up on this one? Can she really buy 7? No, she can only buy 6. So 6 bunches is all this time. So sometimes you have to think. You have to use your brain and think a little bit about what makes sense in context of the problem. Okay, so the context of the problem matters here. All right, let's move on. So if each basket, this is like a little number riddle here, if each basket holds the same amount of apples, how many apples are in the baskets? All right, these are one of my favorite analogies here because the baskets represent a variable, x, and there's 2 baskets there. So there's 2 multiples of something, 2 times x. That's what the baskets are represented by. Now the apples I'll do in red. We've got, looks like we've got 9 over here. And then we've got 1 on this side. So 2 mystery multiples, 2x, plus 1 more, a little lone apple that's not in a basket. Apparently that equals 9. So what do we have? Well, another way to think about that is if you eat this apple and eat this apple, now you got 2 baskets make up 8. So each one has to have 4, right? X equals 4. All right, so these equations represent word problems. And in this case, the variable represents a mystery multiple that was inside that basket, and we didn't know how many were in there. All right, let's move on. So what is the definition of the word solution? So why don't you say it out loud? Now listen. Okay, I didn't quite catch that, but a solution is a number that works in the equation, right? It answers the original problem. But I like to think of it as a number that works. If you were to plug it in and check your answer, it ought to work. Okay, so make sure you check your answer. So what is the solution to that? We said the answer was x equals 4. This was the answer to the last one. How could we check it? Well, 2 times 4 plus 1 equals 9. 8 plus 1, does that equal 9? Big fat question mark. Yes, it's a solution. So we could plug and chug to check to see if it's a solution. Now there are properties of equality, and all this means it's those 4 things that you learned in Algebra 1, where when you're dealing with an equation, as long as you do the same thing to both sides. So I've got 2 here and 2 over here. Okay, as long as I get rid of both of them, my balance is still balanced. It doesn't get messed up. That's really important to understand. That's something you need to just No, I like to call it your algebra spidey sense. When you mess up the balance, it ought to feel wrong. Like, Mr. White, was that maybe not what I should have done? Well, right here, we have an equation, and we're going to minus 2 on both sides. Perfectly legal move. It's the property of equality regarding addition and subtraction. So now we have x equals 5. And that's the answer, right? This box, it could be a basket. We don't know what it is, but it is the same thing as 5. Okay, and we use the property of equality to do that. So you can add, you can subtract, you can multiply, and you can divide on both sides. All right, so 4 different things. Trying to get my fingers in the camera here. So you can do the same thing on both sides. Now you can even remove baskets from both sides. So right here in this problem, we have a basket here and a basket here. So we can remove baskets from both sides. So I'm going to remove just one basket. Now, why would I do that? By the way, you always have to do the same thing on both sides. And here's the middle of the problem. So that's why I put a negative x on both sides. I'm removing a basket on both sides because that way it doesn't mess anything up with the balance. Now, why did I choose to not minus 6x on both sides? I could have done that, but then the whole problem goes negative, and I like to stay positive, right? We like to stay positive in math class. We can do this. So 5x minus 10 equals negative 2. So now we have an equation. We take a deep breath. We move on with our life. What I mean by that is we can literally forget everything up above and just continue working here. So we're going to add 10 on both sides. 8 equals 5x. Divide by 5, and we get x equals 8/5. And you can leave your answer like that, or I believe that is 1.6 if you want to write it that way also. But I'm fine with fractions. Okay, so properties of equality, you can add, subtract, multiply, and divide numbers and or variables to both sides, because the goal here is to isolate the variable. Isolate means get it by itself. Hopefully you've never been isolated in a classroom because you're being bad, right? Gotten put by yourself. So we want to isolate the variable here. All right, we are getting close to done here. Let's take a look at this problem. Now, before I jump into this, why don't you pause the video and see if you can do it yourself? It's always a good way to try. There's something extra here at the beginning. Do you remember what that's called? It's called the distributive property. You have to launch those missiles of multiplication, and those 2 arrows that I just drew are supposed to remind you to multiply. Multiply everything there. So you end up with 4x minus 8 equals 6x minus 10. All right, so if you haven't done it on your own yet, now pause the video and give it a try here. You got variables on both sides. I'd love for you to deal with the variables first. And no, you don't have 10x. Don't write 10x. Okay, so we want a minus 4x is how most people would do this. And I like to deal with the variables first. Now, if you added 8 or added 10 first, it's okay. You need to be careful if you do it that way. Just trust me, I've been doing this for 19 years. All right, deal with the variables first. You got it? All right. Negative 8 equals 2x minus 10. So now I've got let me highlight this guy. I got 1x all by itself, not all by itself, but 1x sitting there that I want to isolate, I guess is my point. I don't have 4x on this side and 6x on the other. Where's my hand? There it is. Okay. We want to get them on one side. So now all the variables are on one side. So now you treat it like everything else needs to get to the other side now. So I'm going to add 10. 2 equals 2x. So x equals, and you divide both sides by 2 at this point, x equals 1. X equals 1 is the answer here. Now, I would like to share with you a common mistake I know some of you are going to make, and it might just be an accident, a little silly goof sometimes. But at this point, I see, folks, minus 2. What is wrong with that? Why can't you do that? Maybe some of you are even thinking that. Why is that wrong? All right, the answer to my question is that's wrong because the 2 is attached to the x by multiplication, and the only way you can undo multiplication is with division. So you could divide everything by 2 right now, but that can get messy, and just trust me, always see if you can add or subtract to the other side first. And then the last thing you do is multiply or divide, in this case divide. So x equals 1. All right. So, oh my goodness. So this is often, it's like I'm showing Dracula the Cross here. We got fractions on the screen. So how do we deal with this? Well, fractions are numbers too, okay? Fractions are numbers too. Decimals are numbers, whole numbers are numbers, fractions are numbers too, which means you can add and subtract them if you need to. Now, it just so happens that this is a plain old number and this is a plain old number, and, aren't I nice, the denominators are already the same. So you can literally just add 7/4 to both sides. So you get 4/3 x equals. Now, when you add fractions, listen to me, please. Listen. When you add fractions, you have to have a common denominator, all right? We got a 4 here. All you do is you add the tops. All right, we got a -5. I like to think of that as a -5 plus 7 is 2. And then the denominator stays the same. Okay, so we get 2/4. So 4/3 x equals 2/4. Now don't freak out on me, we're almost there. Our goal is to get rid of the 4/3. I'm going to give myself a little more room here. Now let me show you something that's really confusing. Don't do this. Divide by 4/3. Oh my goodness. That looks insane. And it confuses even me, so I don't want it to confuse you either. So instead of dividing by 4/3, we are going to multiply by the reciprocal. We're going to flip it over and multiply. Multiply by the reciprocal because then everything gets canceled and x is by itself. See, our evil plan worked here. We got rid of the 4/3. We want to get rid of fractions, right? Because we hate them. So if we multiply by the reciprocal, it will get rid of the fraction. Now, whatever you do to one side, you have to do the other. So times 3/4 on the other. Now, multiplying fractions is different than adding. Multiplying, you don't need a common denominator. Let me repeat that. When you multiply fractions, you do not need a common denominator. Multiplying fractions is actually the easiest thing. All you do is multiply straight across. So you multiply the top, and we get 6. Multiply the bottom, you get 16. Now those numbers are both divisible by 2, so I'm going to reduce this fraction. If you don't reduce, it's okay. I'm just thrilled you got to 6/16 correctly, but it's also the same thing as 3/8. You should know that. Now I don't want the decimal. I don't want to see anything rounded or anything like that. Okay, we have one more problem to do, and this is a special one, literally. It has what we call a special solution. So let's remember what these were like in Algebra 1. Again, everything I'm going over was from Algebra 1, so hopefully it feels familiar, and you can always rewatch this video if you need a review. Now, I would encourage you to just pause the video for a second and see if you could do the first thing for me, and that is do any distributive property that you possibly can to it, and then write it down below. So pause the video and give that a try. 3, 2, 1, pause. Okay, so we have 4y. Now this is really -1 times the quantity. So we're going to launch our -1 in here, which we get -7y. Now look at your paper. Do you have -2? That's a common mistake, is to write a +2 there. So make sure you have -2 equals 9y. Now once again, we have a minus and a 3 being launched in. So don't forget about the minus part. So we get -12y, and then here's another danger zone, is the longer arrow, the long missile there, -3 times -5, and we get +15, +15. Okay, so let me highlight the danger zones. Right there, that sign, I often see students put a minus there, and then this sign right here, I would often see students write a plus there. So make sure you got that right. Okay, so what's the next thing we do? We actually haven't seen a problem like this yet. We've got variables everywhere. So our goal is to get them together and hopefully on one side. So these guys are already together and they're on one side. So what does 4 and negative 7 give you? So 4 steps forward and then 7 steps back. Where are you at? You're negative 3y. I see it as a battle between two numbers because for me, it's like a game, all this math stuff. So I see positive 4 on one team, like the green team, and then I see negative 7 on the other team. So who wins by how much? The negatives by 3. They've got more on their team, so that's what I got when I combine those. All right, so minus 2 equals, now on the right side, I also have y's. So it would be y's to work with those. Yeah, get used to it. A lot of bad jokes in my class. All right, so negative 3y plus 15. Okay, so you're pretty happy or just going about your merry way here. And then, you look back in your notes and you say, well, Mr. White told me I should deal with the variables first. Always deal with the variables first. So let's do that. I see negative 3y there. Okay, great. Let's add 3y. Add 3y equals minus 2 equals what? All the y's just disappeared. All the y's are gone. So what are we going to do? Well, we're just going to write nothing there for now, and I'm going to bring the 15 down. So the question is where do we go from here? Well, we're actually done. We have the answer. All I need you to do is ask yourself, is that true or not? Is negative 2, is that the same thing as 15? No, of course not. Not true. So there's no solution here. There's no number that you could ever dream up that if you plugged into the original equation, it would work. Never going to happen. You could try until, your little heart's desire, whatever the phrase is, and you're never going to find a number that will plug in and work. So it was doomed from the beginning. It was doomed from the beginning, no solution. Now, the opposite of no solution is if you get a situation where you do all that work, and then the x's or y's or whatever it is disappear, and you get 5 equals 5, or 0 equals 0. And that's a true statement. So what do you say then? Well, then the answer is all real numbers. Or sometimes we use this R that looks like this. You do 2 vertical lines and then an R. So if it comes out to be a true statement, the answer is going to be all real numbers. If it comes out to be a false statement after all the variables disappear, then you've got a no solution situation. All right, let's see if I can pull up my camera again here. Oh, there we go. Hitting the right button. So hopefully you learned something here about solving equations. We reviewed it, and maybe I helped you understand how to add, subtract, multiply, divide, maybe pluses and minuses. I have a lot of different ways that I like to teach these and think about myself so that I can do things without a calculator. So I'll try to share those little insights with you throughout the year. All right, there will be some homework posted on Google Classroom, so be sure to get up on there and see what you need to do. All right, take care, guys.